Now we have exercise 6.15. From a uniform disk of radius r, a circular hole of radius r by 2 is cut out. The center of the hole is at r by 2 from the center of the original disk. Locate the center of gravity of the resulting flat body. Okay. Very less chance for this question, but still, if they ask advanced questions, this question has a chance. That's what. I'll illustrate the question. We have a disk. All right. We have a disk like this, and the radius of the disk is r, and you're going to cut a small disk out of it. Small disk out of it. What is the radius of the disk you are cutting out? It is r by 2. It's in fact r by 2. All right, it's r by 2. Okay, so this is r by 2. All right, so this is the situation or context. We have a huge disk with radius equal to capital letter R. The radius of the cut portion is r by 2. The radius of the cut portion is r by 2. First of all, I'm going to find, so this is the cut portion. The unshaded portion is the cut portion, okay? Now this is like a hole in the disk. Look at that. Shaded portion is what remains now. Unshaded portion is removed. Okay. Now, I'm going to find the mass of this. What is the total mass of the disk? I assume that the total mass is m. So what is mass per area? Mass per area is m divided by pi r square. This is actually mass per unit area. That means if you take unit area on the disk, unit area means 1 centimeter length, 1 centimeter breadth. The mass per area, this is called mass per area. I'll write it that way. See this? I'll write from the beginning, okay? Mass per area of the disk. It is what? Total mass by total area. Total mass by total area. This is mass per one area, unit area. So, what is mass of cut portion? Mass of cut portion. Mass of cut portion is equal to, this is the cut portion, right? Mass of cut portion is equal to mass per area into area of the cut portion. Because for 1, it is m by pi r square. 2, m by pi r square into 2. 3, m by pi r square into 3. 4, m by pi r square into 4. R by 2 radius, m by pi r square into pi r by 2 the whole square. Let us cut this pi and pi. Then this becomes what? M into r square divided by 4. There is an r square here as well. So you get what? R square and r square cut. You get this as m by 4. So mass of cut portion is m by 4. So what is mass of remaining portion? Mass of remaining portion. Look at this. Total mass minus mass of cut portion. Total mass minus mass of cut portion will give you mass of remaining portion. Remaining portion means this shaded portion. What is it? M minus m by 4 is 3m by 4. So I'll just go through the steps one more time. First of all, this is the situation. We have a disk. The radius of the disk is capital letter R. The radius of the disk is capital letter R. Okay. And the radius of this disk is r by 2. R by 2. Okay. And this much portion is cut out from it, which means that's like a hole now. Okay. And then what? The question is, I'm going to find the mass of cut portion. It's a standard procedure. Mass of cut portion. How to find it? Mass per area into area of the cut portion. Mass per area into area of the cut portion. Mass per area. Mass divided by area of the whole disk is pi r square. Into area of the cut portion is pi into r by 2 the whole square. R square cut, you get m by 4. So mass of cut portion is m by 4. Mass of the remaining portion is m minus m by 4, which is 3m by 4. Now, they are asking you to find the center of gravity of the remaining disk. how to find it? I'll just do it. Center of gravity. Center of gravity of the remaining disk. Just assume that the center of gravity of the remaining disk, center of gravity of the remaining disk is here at a distance of x. At a distance of x. All right, x. Okay, at a distance of x. Just imagine the center of gravity of remaining disk is at a distance x. Because when the portion is cut, center of gravity will shift to the heavier part. No? So mass is concentrated here. It's finished now. So how to take? This is the original center of gravity. Original center of gravity. Look at that. About which the moments are balanced. The moments are balanced. You can say M1 R1 should be equal to M2 R2 about center of gravity. M1 into R1 should be equal to M2 into R2. I'll tell you, mass of the remaining portion, that is 3m by 4. Mass of the remaining portion, that is mass of the remaining portion into its distance, x should be equal to M1 R1 should be equal to M2 R2. Mass of the cut portion, which is m by 4 into distance r by 2. So if you cut them m by 4, then x will be what? X will be equal to r by 3 comes there, 6. So that is at a distance of r by 6. Actually, this is one of the toughest questions, but I'll keep repeating this until you understand. So first of all, what is the question here? We have a whole disk, okay, disk, whose radius is capital R. And you are cutting a portion out of it. What portion? You are cutting a portion out of it, like this. As a portion with radius equal to r by 2. With radius equal to r by 2. Now, this shaded area is what? Shaded area is the remaining portion, okay? The cut portion is what? The cut portion is the unshaded region. The cut portion is the unshaded region, okay? Unshaded region. All right. So this much of mass is not there. How to find it? How to find that mass? Mass per area. First thing to do is to find the mass per area. Total mass divided by total area. Total mass is m. Total area for the whole disk is pi r square. So I get mass per unit area. Then for this portion, how to find the mass? Mass per area into its area. Mass per area into its area. What is mass per area? M by pi r square. This area is how much? Pi into r by 2 the whole square. Pi and pi r cut. This is m by r square into r square by 4. R square cut, I get m by 4. I get the mass of cut portion, removed portion. Correct. So what is mass of remaining portion? Total mass is m. Mass of cut portion is m by 4. So the difference is 3m by 4. Now we know one thing, that the center of mass, above the center of gravity, the moments will be equal. So if we have two masses like this, if this is center of gravity, this distance into this mass should be equal to this distance into this mass. That's called principle of moments. M1 R1 plus M1 R1 is equal to M2 R2. Moments about center of mass will be equal. So this mass into its distance should be equal to this mass into its distance to the original center of gravity. So this mass is how much? We calculated it. It is 3m by 4. 3m by 4 into distance is x should be equal to this mass, which is m by 4 into this distance is r by 2. So m and m are cut, 4 and 4 are cut. Solve it. You get x is equal to r by 6. Understood this? Otherwise, I can do it again.